All right, let's have a look at the problem. It's called sum of two integers. Given two integers a and b, return the sum of the two integers without using operators plus and minus. Okay, so we have to do the sum, but we cannot do plus and minus. So essentially, then it comes to okay, we do some binary bit magic, and then based on that bit manipulation, we do addition. And it would help if you're already aware of a half adder, full adder implementation that actually uses those gates, the binary, the logical gates, the logical operators. Let's actually discuss it on a whiteboard. So let's take an example of a equals to 2 and b equals to 3. So we have just a sec. So we have a equals to 2 and b equals to 3. Now, obviously, and a plus b equals to 5. So let's first look at addition of a single bit, right? So there can be two different things. One is okay, 0 plus 0, 0 plus 1, 1 plus 0, and 1 plus 1. Obviously, 0 plus 1 and 1 plus 0 is same, but okay. What this gives you is 0, what this gives you is 1, what this gives you is 1, and what 1 plus 1 gives you is 1, 0. And we can also call uh, this as the sum, and we can call this as the carry, right? And so we get here the carry is 0 and the carry is 1. Now, if you observe it carefully, you can obviously see that sum equals to a x or b and carry equals to a and b, right? That's quite clear. And obviously, if you do it over multiple bits, um, and okay, before even going to that, so when we do sum and carry, how do you integrate sum and carry into each other? So when you do list 1 plus 1, your sum is 0 and your carry is 1. How do you add both of them up? So when you get a carry, what? So here, for example, 1 plus 1, you get sum equals to 1 and carry is also, sorry, sum equals to 0 and carry equals to 1, right? So now what do you do? So what you do is you do sum plus whatever carry you got, you left shift it by ones, right? So essentially you had sum as 0 and then you do plus carry as 1 0, and because you shifted carry by 1, and that's how you get this 1 0, right? So what I'm trying to get at is let's say now we do 2 and 3, right? So 2 is 0 1 0 and 3 is 1 1. So if you were to actually do a sum like bit by bit, so 0 plus 1 is 1 and 1 plus 1 is 0. And if you, and then there is a carry 1 and that carry 1 gets added here. But essentially you could also look at it as, okay, so if I just do XOR, right, of 1 0 and 1 1, what would I get? I will get this. And if I just do AND, what will I get? I'll get this. So if I do carry left shifted by ones, I'll get as 1 0 0, and I'll add this with the sum which is 0 1, then I will get 0 1 and 1 0 0. And again, for doing sum, I do the XOR, right, which would be 1 0 1. And this is my final answer, because now if I also do a carry, so if I try to get carry out of this, I'll get 0. So I'll keep doing this recursively till my carry becomes 0. And this will be my answer, right? So that's the general idea, where sum equals to uh, a XOR b and carry equals to a and b, and actually carry, you then maybe use carry as this, like, and you want to left shift and then add, and then you do keep doing till and then basically sum is what you can treat as a and carry is what you can treat as b, right? Keep doing till carry is 0. That's the general logic. That's implemented in code. So to start with a basic understanding, let's do something like this. So to begin with, let's say, hey, my sum is equals to a x or b, and my carry is equals to a and b. And now actually carry is a and b less shifted by one, right? I'll do a and b and I will left shift it by one. And while my carry is not equals to zero, I'll actually keep doing this. So I'll get a new sum, which will be sum XOR carry, and so I'll call it new sum, and I can do new carry equals to sum and carry, right? And then I can do hey sum equals to new sum and carry equals to new carry, and at the end I will return this sum, right? That is one way of looking at it. And if you really think we can avoid this sum and carry also, we could do something like again, this is has to be this has to be left shaded by one. First, let's check whether for the initial test cases this work or not, and it does work. Now, obviously, this bit some carry is being repeated once outside as well. We could potentially not do that, right? So we could essentially not use a sum and carry and use a and b in that place. So we can here say while b is not equal to 0, and we can do hey, so my sum will always be ax or b, right? A XOR with b, and my carry will be equals to a and b left shifted by once, and then all I can do is this, I can replace a with sum and b with carry, right? And I can do return at the end, return a, and let's submit. Okay, the semicolon, submit, and that's it.